13 Universal. So this is 13 Universal. So you're welcome. Welcome to 13 Universal. This is Learning Beyond Barriers, and with you today is Shedro, your bio teacher. So guys, we're doing biological molecule. Is that okay? So biological molecules, part two, part three. This is part three. Okay. So we have done part two. We have done part one. So you read it up. You can watch the video on part one and part two. So this video is on part three. All right. So the question is, what are biological molecules? Just to recap, we said that biological molecules are what? They are building blocks, right? Building blocks of life. Okay, building blocks of life. Don't forget. All right. So if you look at this cell, can you see this cell? This cell as a whole is made up of this biological molecule, right? Which looks like an amino acid. Okay, no. This is a carbohydrate glucose, all right? This is another biological molecule, which is an amino acid. This is glucose, the glucose. This is lipid, that is under lipid triglyceride, and this is DNA. They're all made up of, all right? They are part of this entire cell. Okay, so this cell is built from this molecule. So we discuss factors that affect facts about biological molecules. We'll discuss all of that. Is that okay? We'll discuss all of that. But one of the facts you can see that they're always made up of monomers, all right? Especially for some of them that are polymers. Okay. Yeah. And then the polymers undergo condensation reaction or polymerization to form polymers. Okay, this is very important. All right, let's go. Today we're discussing proteins. Let's go to proteins. Come with me. So look at what we said here. That proteins are very important. Are made up of amino acids which only differ in R groups. Okay, the R groups of amino acids or variable side chain and will always contain an amine group, basic group. So amine group is basic group. Carboxylic group, okay, is the acidic group and a hydrogen atom attached to the central carbon atom. I think what it's trying to say is that proteins are made up of, you know, we have proteins, okay? Um, Proteins, they are polymers of amino acids. So they're made up of amino acids, okay? Yeah, so amino acids are the building block, just like we showed you here. That this is like amino acid here. Amino acid undergoes polymerization and then they form um protein, right? So the bond between them is called peptide bond. Okay, the bond between the amino acids, this bond here, that bond is called peptide bond. It links the amino acid. All right. So let's get back to what we're saying, right? So, but I also want you to know there's a difference between protein, right? If you're saying protein, okay, versus polypeptide. Okay, very important. Protein versus polypeptide. Now, a polypeptide is a polymer of amino acid, just like a protein, right? But a polypeptide is just a chain. Talk about polypeptide is like chain of amino acids. So when poly means many peptide bond, many amino acids, all right, joined. But a protein can be made up of one, all right, or more polypeptides, okay? Yeah, a functional structure, one or more polypeptide. So that's different. So if you look at that, we have mentioned amino acid. So amino acid is the monomer of polypeptides, okay, and protein. So this just like what they were trying to say here. So if you check, this is like an amino acid. This is structure of an amino acid. So you see, now this is the it has two groups here. Okay, okay, it has three groups. See, so when it was said that amino acid are made up of R group, now this is R group here. This R group is what we call variable group. That's what makes one amino acid different from another amino acid. But all amino acids have amine group. You can call it amine group or amino group. That's amine group. And like we are told here, that amine group is basic. Can you see? So this is basic. There's also made up of all amino acids have carboxylic group. That's carboxylic group. So carboxylic groups are what? You know, they are acidic. Is that okay? And they also have hydrogen atom. You can see attached. Now that's the hydrogen atom. Okay. And attached to the central carbon atom. This central carbon atom is called alpha carbon. Is that okay? Alpha carbon. Is that okay? Alpha carbon. So all amino acids have same amine group, right? Same carboxylic group, same hydrogen, same alpha carbon, but they have different R groups. Okay, so the R groups is what you know makes them different. But I want you to know, guys, this is very important. Okay, this amine group here and the carboxylic and this carboxylic group here actually is better we call it terminal. So terminal carboxylic group and terminal amine group because they are the both ends of the amino acid. So this amino acid is from here to here. So why this is terminal carboxylic group, this terminal amine group, okay? And then what is their major? The major advantage is that peptide bond is usually formed between the carboxylic group of an amino acid, okay? That is the terminal carboxylic group of an amino acid and the terminal amine group of an adjacent or neighboring amino acid. This is very key, guys. Don't forget it. Okay. So these two help to form peptide bond. But you see, R group is what makes them different. Okay. So R group helps to form bonds. Okay, between amino acids. We're going to discuss that later. So R group between adjacent amino acid, forms bond like hydrogen bonds. I don't know what I heard about hydrogen bond before. Okay, bond like ionic bond. Is that okay? You know, disulfide, disulfide, the sulfide bond. Okay, and then hydrophobic interaction. So let me write it here. So about four bonds are formed between the aryl groups of adjacent amino acids. So these four bonds are hydrogen bonds, ionic bond. We'll discuss them in the next episode. Disulfide bond and hydrophobic interaction. All right, we'll discuss them in the next video. But I just want you to know that it's formed between R groups of adjacent amino acids. Okay, that's very key. And these bonds helps to fold. They actually help to fold or call proteins. They have to fold or call proteins to give them, specific shapes. Like they give them the secondary structure we'll discuss later. All right, give them tertiary structure and of course quaternary structure. So quaternary structures, tertiary structures, secondary structures are due to the bonds formed between amino acid, all right, the R group of amino acid, bonds such as hydrogen bond, ionic bond, disulfide bond, and hydrogen interaction. Okay, so this is very important. Okay, but peptide bond is formed between the terminal carboxylic group of an amino acid and the terminal amine group. So you see that this carboxylic group can also be part of R group. Okay, but if it's not a terminal, it cannot be used to form peptide bond. Peptide bonds, peptide bond is only formed between the terminal carboxylic group and terminal amine group. Terminal carboxylic group of one amino acid and terminal of another. I will show you that later. Okay. So, for example, now you see that I told the R group determines amino acid, right? So, if the R group is hydrogen, mm, this amino acid, you can call it lysine, right? Lysine. If it is disulfide, okay, you can call it cysteine. Don't forget that. So there are different amino acids. Oh, let's go, guys. So this is a polypeptide you can see. So it's a chain of amino acids. See this amino acid lysine. And this is a terminal, all right, amine group of lysine. The lysine joined to glutamic acid, proline and all of the alanine and alanine. See, these are chains of amino acids linked by hydrogen bonds, all right, forms polypeptide. Okay, and it's not going to have terminal carboxylic group and terminal amine group. Do you get? Okay. So you can see that they are beginning to fold. Can you see that this polypeptide is beginning to fold? Why? Because bonds are formed between the aryl group of amino acid. All right, aryl groups. For example, the bond is formed between this cysteine and this cysteine. And you know, cysteine, like I told you, cysteine, okay, is amino acid that contains disulfide group. So the bond that is formed between two disulfide group, all right, is called disulfide bond. So the disulfide bond is only always formed when two cysteine amino acid come together. We'll discuss this, okay? So we can see that bond here. That should be a disulfide bond. We'll discuss it later. See another cysteine disulfide bond, all right? See wherever they appear. But it's okay. But just know that this is polypeptide chain. Let's go, guys. Let's get into the game for today. Okay. All right. So see what I'm trying to say, guys. See what I'm trying to say here. That's carboxylic group, all right? Carboxylic group, right? This is called alpha carbon, right? This is amine group. Is that okay? Hmm? This is terminal. Remember the terminal. Terminal. Why did I choose to put terminal? Because it's possible to have an amine group or amino group on this R group. That group could be an amine group. Is that okay? Yeah, it could be a carboxylic group. So we have terminal amine group, like I mentioned, and we have terminal carboxylic group, and it's between them that peptide bond forms. Okay, guys, let's go. So yeah. So knowledge check. Let's check knowledge. It says the R groups, okay, the R groups are called side chains of amino acids can be hydrophobic, yeah, depending on the R group. It can be hydrophobic, hydrophilic, acidic, or basic. The diagram shows four different amino acid R groups. Which row is correct for these amino acid R groups? So I want you to pause the video and check this. All right. So if you check this amino acid, this is alanine. Pause the video and try it. Aspartame, lysine, okay, serine. So which of them is hydrophobic? Hydrophobic means non-polar. Okay. Now this is not charged, so it must be hydrophobic. This is charged acidic. That's basic. That's hydrophilic. Okay. So this is acidic. This is basic. This is okay. Hydrophilic, and they're all, you know, so you see that this is um this is alanine is hydrophobic, right? So that goes for this and this, cancel this, and it's a hydrophilic, the one that has um hydroxy group, all right, which is serine, goes for this and this. Acidic is the one that has carboxylic group, which is aspartame, okay. Lysine is not acidic. Is that okay? And basic is the one that has amine group, which is lysine. So the answer is actually A. All right. So let's go to the next question, guys. I want to check this knowledge check. The diagram shows the structure of four amino acids in aqueous solution. Okay. Sorry for the background noise. The diagram show the structure of four amino acids in aqueous solution. So these are the four amino acids. This is glycine. That is lysine. This is number three, alanine. Number four, aspartate. They say which two structures have an overall charge? Now, if you check this, this is negative, this is positive. Uh, no overall charge. This is positive, this is negative, nothing here. So this is none, no overall charge. Right? This is negative, this is positive, they cancel out. But there's a positive charge here. This is positive. This is how overall charge of positive. Right? If you check this, negative, positive cancels out. But there's a negative here. So this is negative. So that means lysine has an overall charge and aspartate has an overall charge. Lysine and aspartate, right? Where is it? Aspartate and lysine, that's C. So it's not this, not this, not that, but that. Okay. So let's go to the next concept. So a peptide bond is formed by condition between two amino acids. Now, guys, let's get into how peptide bonds are formed. Okay. Yeah, forming. Yeah, it's formed. A peptide bond is formed by condition reaction. Yeah, that's a reaction. Remember that monomers undergo condition reaction to form their polymers. All right, between two amino acids, forming a dipeptide bond. Many amino acids that join together bipeptide bond. Bonds form a polypeptide. So when they keep forming, listen, an amino acid keep forming again, right? When there are many of them, we call them polypeptide, right? Let's see how that works. So look at this, guys. So this is glycine. How do I know it's glycine? Remember that R group is hydrogen, okay? Reaction to another glycine, R group is hydrogen. So during the reaction, the terminal. Remember, I told you guys that look at what we say that peptide bond is formed between the terminal. You see, can you see this is carboxylic group, and this carboxylic group of this glycine molecule, and this carboxylic group is the terminal, right? So peptide bond is formed between the terminal carboxylic group and the terminal amine group. Terminal carboxylic group of an amino acid and terminal amine group of an additional amino acid. So this is also terminal, right? How do I know? Is at the end. It attaches both of them. Every amino acid will have terminal amine group and terminal carboxylic group, and they both are attached to one carbon atom. You get? So this is terminal. How do I know? Because a terminal amine group attaches the same carbon atom as a terminal carboxylic group, right? So it's not the amino acid or carboxylic group on the R group. The one that forms peptide bond is the ones that are the terminals, right? So you can see that the OH of this terminal carboxylic group reacts with the hydrogen of the terminal amine group to form water. See that? And then peptide bond is formed between this carbon here and the nitrogen. Can you see? So this is the peptide bond. So all of these are involved in the formation of peptide bond. So it's formed between this carbon and this nitrogen. So that's peptide bond, guys. Okay. Now, don't forget that you can be asked how many atoms are involved in peptide bond. How many atoms make up peptide bond? I said this is carbon, one. Okay, that's one. Oxygen, two. Hydrogen, three. Nitrogen, four. Okay, four of them. Now, by the time you join two amino acids together, you're going to form a peptide bond. Now, this is a peptide bond. Is that okay? From here to here is a peptide bond. A, sorry, a peptide bond is this. This is dipeptide. Sorry. When you join two amino acids, you form dipeptide, not. All right. The bond that links the two amino acids is called peptide bond. But the structure that is formed now is called dipeptide. Why is it called dipeptide? Because it consists of two amino acids. Di means two. Is that okay? All right. Well, dipeptide consists of what? Two amino acids. Is that okay? Two amino acids. So you see that in every dipeptide bond, sorry, all right, every dipeptide, we can say that, let's assume that number of N is equal to number of amino acids, right? And then I have that maybe X, okay, is number of um, peptide bonds, right? Peptide bond. So you can see that number of peptide bond, okay, is equal to number of amino acid minus 1. Don't forget it. Hmm? Number of amino acid 2 here. 1, 2. How many peptide bond? No, X number is 1, just this one, okay? So that means that when you count the number of peptide bond minus it 1 to give you the number of, sorry, if you count the number of amino acids, when you count the number of amino acids and minus 1 from it, it will give you the number of peptide bond. So if you're asked in a question, for example, that a polypeptide consists of 140 amino acids, is that okay? 140 amino acids, and you're asked the number to calculate the number of, right? Number of peptide bonds. What will be the number of peptide bonds there? You know how to do that, okay? So number of peptide bond X is equal to number of amino acid minus 1. Okay? So that means number of peptide bond will be 140 minus 1, which will be what? 139 peptide bond. Don't forget that. Okay? So you could also be given peptide bond and you are asked for the number of amino acid. Remember that the number of amino acid, right, and will always be number of peptide bond plus 1. Okay? So this is for number of amino acid. Okay? So if you are told that X, which is peptide bond, is 38, right? So what will be the number of amino acids. That will be N will be equals to 38 plus 1. That is 39. Is that okay? Yeah. So that's number one. Very important. But guys, also if you check, remember that so in every dipeptide, okay, in every you have two amino acids. Two amino acids. So if I have 8 amino acids, okay, if I have 8 amino acids, what are the possible dipeptides that I can form, that can be formed? Possible dipeptides that can be formed. Possible. Now, this is when you use, okay? Remember that each one will form, okay, two different amino acids or two different amino acids. We have 8 amino acids. That will be 8 raised to the power 2, okay, which is 64. Don't forget these calculations. So if I have, for example, I have 12 amino acids, 12 amino acids. So what are the possible dipeptides that can be formed? Just say 12, all right, is number of amino acids raised to the power 2, which is 144. Don't forget that. Right, let's go to the next one. Knowledge check. Yeah. So the diagrams show the structure of two amino acids, each of which has two amine group. Yes, amine groups. So you see, you can see what I'm trying to say, right? This particular amino acid has two amine groups. This is an amine group, this is number one, and number three is also an amine group. So which one, right, do we need? Now, if you check also, this one has two amine groups, right? And the question says a peptide bond is formed between the two amino acids. Which groups form the peptide bond? Remember what I told you, all right? So I want you to pause the video and check it. Try to solve this question. So which group will form the peptide bond? Which one? Okay. So remember I told you, pause the video and try it. Remember I told you that peptide bond is formed between terminal, all right, carboxylic group, right, which is COO, right, um, and terminal of an amino acid, okay, against terminal amine group, right, of another amino acid, which is NH2, right? So remember, this cannot be terminal amine group. Why? Because it is not attached to the same carbon atom with a carboxylic group. As a matter of fact, this amine group is part of R group. So from here to is R group. The R group of this amino acid is this. The same thing here. The R group of this amino acid is all this group here, all these atoms, and this group here. That's the R group. Okay. So this is the terminal amine group of this amino acid. That's carboxylic. This is the terminal. All right. For this, this is carboxylic. Very important. So now, so either the bond is formed between 2 and 4. All right. Is there an option that has 2 and 4? No. Or is between 1 and 5? Is there 1 and 5? Yes. So why is A wrong? 1 and 4 are two amine groups. So peptide bond is not formed between two amine groups. Why is 2 wrong? 2 and 6, 2 and 6. This 6 is not a terminal carboxyl amine group. So this is wrong. Why is D wrong? Delta is 3 and 5. 3 is not a terminal amine group. So the answer is B, because 1 is a terminal amine group, while 5 is a terminal carboxyl group. So the peptide bond is formed between them. All right, let's go and check it out. See you see what we discussed is coming out again. What is the theoretical number of chemically different dipeptides? Chemically, like different possible combinations, dipeptide that may be assembled from 12 different types of amino acid. So what will be the answer? 12 different amino acid. Calculate it. You don't know how to calculate it, you can go back and see how I explained it. But like I told you, if you number of possible, right, different possible dipeptides, okay, is equal to number of amino acid, right, raised to power 2. So the number of amino acid is 12, sorry. Yeah, that's 12. 12. This is 12. So that's going to be 12. Yeah. raised to power 2, which is 144. Okay, so the answer is C, Charlie. All right, look at this question. So the diameter of some atoms when they form bonds are given in a table. So this is hydrogen atom single bond, oxygen. Okay, we have the single bond, double bond. Is that okay? Now it says the approximate length of the amino acid shown below was estimated using the figures in the table. Okay, the length is from here to here. Okay, what would be the approximate length of dipeptide form during this using this amino acid? So I want you to try to solve this question. Okay, pause the video and try to solve the question. So the first thing I want you to know is that how did we get from here to here to be 0.7 nanometer? So this was given. We're asked to find that of the dipeptide. Remember that to create the dipeptide, we have this join the two amino acids together. All right. This is we're just trying to draw the how dipeptide is formed. So this is amine group, hydrogen is here, right? So this is R group, all right? And this is H. If you react two of them, you're going to have, of course, this is nitrogen, hydrogen, hydrogen. This is going to be R here, okay, R group, okay. This is going to be, of course, carboxylic group, all right, that's hydrogen. So water will be formed, remove water from them, and then by the time you draw it, you're going to have the dipeptide. This is condensation reaction. We're going to have something like this, okay. Yeah, so you have this. So let's flesh it out. This is carbon. This is right carboxylate. You're gonna form peptide bond between these. Right. This is R group, hydrogen. This is carbon R group here. Okay. So what I'm gonna do is they want to know the length of the dipeptide, guys. Hmm? Don't forget that this no, this is this nothing is here. R group is here. Yes. Hydrogen is here. So we want to know this from here to here. Simple. So what is the length here? So let's calculate. Remember that just add up. If you join, if you this is hydrogen, nitrogen, carbon. This is the length here, guys. Okay. So I'll ask myself, how many hydrogens so do I have here? This is number one hydrogen. Okay. This is number two. So I have two and the single bond, right? So I'll say two times hydrogen, right? Two hydrogen. If I go, which is two times this 0.060. So what will you give me? So let's press bring your calculator. So two times 0.06, and that gives us what? That 0.12. Okay. So let's go to nitrogen. How many nitrogen do we have here? One. This like two. So that's two times nitrogen. Now, but if we do all of this, it's going to take time, okay? Because I want to show you. There are two ways to do that. Nitrogen, right? So that will be two times single bond for nitrogen. That is 0.140. Okay? So you say two times 0.14. What will it give us? It will give us 0.28. So that's 0.28. Is that okay? So now let's go to carbon. One, two, three, four. So we have four carbon atoms. Four carbon. So and they're all single bond. That will be four times the size of single bond of carbon is 0.154. Right. So say two, no, not four. Four times zero, right? 0.154. 0.54. So what do we have? We have 0.616, I guess. Okay, so let's go to the next one, which is we have done hydrogen, nitrogen, carbon, then oxygen. Okay, only one oxygen here, right? Okay, so only one oxygen, and then of course you can see there's one oxygen as well. That is oxygen here. So that will be 0 point oxygen one bond is 0 point, sorry, 0.132. Okay, so 0.132. I hope you are doing the calculation. I hope you are solving the question. You are solving the question, right? Yeah, let's see what we have. Okay, so what we're going to do, guys, is that we're going to have um we will add up. So put this 0.132, add up everything. So add this plus this plus this plus this. So let's go. We have 0.12 plus 0.28 plus 0.616 plus 0.132. That gives us, right, it gives us 1.148, right? So which option is closest to this? So now, okay, this is close but not so close. This is far away, that's far away. The closest one is B. So B is the answer. Now, another way you can do that, you can also, because since one amino acid is 0.7, you can just add it up 0.7 and that gives 1 point. That's another way, okay? Minus water because we're removing water during this condensation reaction. So if you check water, water is like this: hydrogen, oxygen, hydrogen. So just say remove 2 times hydrogen, right, which is 0.12 plus oxygen, which is 1, that's 0.122. So add them up, minus them from this 1.4. So let's try that and see what we get that. So that means 0.12. So we're adding the 2 here plus 0.32, and that gives us 0.44. Okay, 0.44. So minus it. Okay, 0.44. So you say 1.4 minus 0.44. What does it give you? All right. Oh, if you do that, 0.90 is, well, um, 0.90, that's good. 0.90 is, well, that's also close to the answer, right? But the best thing is to follow this method. Is that okay? Hmm? So you can watch it again and ask us questions, right? Okay, look at this question. The diagram shows 2 amino acids. Some of the hydrogen atoms are numbered 1 to 6. Okay, so which 2 numbered hydrogen atoms could contribute to the production of a molecule of water when a peptide bond forms between these 2 amino acids? Right? Which ones? Remember, pause the video and try it. So you pause the video and try it. Okay. So remember that it is usually formed between terminal carboxyl and terminal amine. So 3 and 4, are they there? Is there any 3 and 4 here? No. So if you say 1 and 4, 1 is this, that's terminal, that's okay. That's 4. Hmm? 4 is here. Now this group is amine group. That is amine group. So you cannot be formed between 2 amine group. So wrong. B, 1 and 6. Okay, this hydrogen is attached to amine group. 6. Okay, is attached to terminal carboxylic group. Yeah, that's correct. C, 3 and 5. 3 is hydrogen attached to carboxylic group. 5 is not attached to amine group. So that's wrong. The hydrogen must come from a terminal amine group. 2 is not attached to an amine group terminal. So that's wrong. So the answer is bravo. So let's go to the next question. Which diagram shows the formation of peptide bond? You should be able to solve this quickly, right? So which one shows the formation of peptide bond? Okay. Yep. Pause the video and solve it. So this shows formation of peptide bond between terminal carboxylic and terminal amine group. Yeah. What about this? Okay. So you see that the formation of the only thing wrong with this is that it's not formed between two terminal carboxylic group. It is formed between a carboxylic group and amine group. So that's what this is wrong. So it's not formed between two hydrogen from amine group and one oxygen from a carboxylic group. It's one between. Okay, water is produced from OH from carboxylic group and hydrogen from amine group. Okay, so this is wrong. The same thing is wrong. Okay, not formed between two carboxylic group. So the answer is A. All right. So now let's check which statement about peptide bond formation are correct. The bond formation occurs between a carbon of one amino acid. Now pause video and try to solve it. One amino acid and the nitrogen of the next amino acid after the amino acid detaches from here. This is correct. Okay, so you see that it is formed like this. All right. Yeah. So what this has this has hydrogen here. They're all joined to. Okay. Yeah. So number 2 says the bond formation occurs at ribosome. Of course, that's where protein is synthesized. While the amino acids are still attached to RNA and is a hydrolysis reaction. It's not a hydrolysis reaction, it's condensation. Okay, because they are joining to amino acid. So this is wrong. Number 3, the bond formation is important for growth of an organism, and when the bond forms, a water molecule is removed. Correct. Okay, so water is removed. So the answer is 1 and 3. And when protein is formed, protein is needed for growth. So 1 and 3 are right. So A is the right option. Okay, you solve this. Pause the video and try this. Which molecules have structural formula that contains CO group? Amino acids have CO group because they have carboxylic group. Fatty acids, okay. The fatty acids, all right, they have CO group, right? So you know fatty acid is like this, okay. Then it has um, carbon chain, okay. You know amino acid now. You know amino acid. See, this amino acid group here. I do. See this CO group, okay? This guy has CO group, right? So this is amino acid, amino, okay? Amino acid. This is fatty acid. Don't forget that these are hydrocarbon chain, hydrogen atoms attached. Glycerol, does it have CO group? Nope. So this is glycerol, right? Remember glycerol hmm? on part 2 of this biological molecule. So this is glycerol. It has three carboxylic group, three hydroxy group. So there's no CO group there. So this is out. Now, protein contains amino acid. Amino acid has CO group. So protein is there. One, one, two, and four. So B. So thank you for watching. Um, kindly watch out for the next, all right, part and leave your questions. Like, subscribe, turn on the notification button. All right, see you next episode, which is part 4. Bye. Don't forget that this is Shedra. Shedro, your biology teacher.